Hey everybody, this is our first video introducing the very small scale. We're going to look at some of the smallest particles of matter and also a property of that matter that you maybe are not familiar with. You do experience it, but it's not the most obvious thing. You don't notice it every day, all right? So to start off with, a term that you may have heard before, it might be new. The term is atom. An atom is a building block of matter. Now, it is far too small to see with the naked eye. Objects that we see are made up of trillions upon trillions of atoms. So I can't actually really show you a real picture that's any good because you can't really distinguish an individual atom, certainly not with the naked eye. Even with modern equipment, it's almost impossible to view actual atoms, but they are the building block of matter, and there are many different types of atoms. I have this image here. I found this online, but I do really like it. What it's doing is it's zooming in. This is a person and maybe like zooming into a vein or an artery. This looks like it's zooming into a computer chip. Here we're zooming into the wing of a butterfly. The basic set of scales that we have is kind of our human scale. We see butterflies, we can see the computer chips in our computers, we can see veins, but if we zoom in and like the person, we have this tissue with blood vessels. All right, blood vessels are made up of these cells, but if we can zoom in on cells, cells are made up of atoms. For computer chips are pieces of electronics. Of course, you know that. If we zoom in, we can see the individual components maybe of a transistor. If you zoom in, they are made up of atoms. A lot of carbon and silicon atoms are inside our computers. Same thing with a butterfly wing. If you can zoom in, here's the tissue of that butterfly wing. It is made up of different cells, which then are made up of different molecules. And if we could zoom in, they are made up of atoms. Atoms make up everything. I also really like this Lego picture. You know, Legos are these building blocks where you have these little small bricks and you can stack them together to build larger things. And that's a very good analogy for what atoms are. Atoms are small things, so small we can't even see them, but by building and combining atoms, you can construct everything. Everything around you, every object is made up of atoms. Your table, your smartphone, even you are made up of atoms. Now, atoms themselves actually have three smaller parts. When we say an atom, there are three parts to an atom. First, in the inside, kind of clumped together, there are two things. In this picture in blue, they show neutrons, okay? So that's one small particle, neutrons. This one here is showing 4 neutrons. In red, in this picture at least, obviously the color can change based on the visual. This is not an actual image of an atom. Remember, we can't really image them. But on the inside, in addition to neutrons, there are these things called protons. There's a third object. Now, it is not located on the inside. The inside area is known as the nucleus. Okay, it's the inside part. The nucleus of an atom has protons and neutrons, but on the outside, whizzing around almost, is things known as electrons, okay, shown here in this picture as green. So here are the three parts, protons and neutrons. They are on the inside part in the nucleus, the inner portion, and then going around, kind of like almost a planet orbiting a sun, though it turns out that they're not really orbiting in that sense, but this is a classic visual. Zooming around, orbiting on the outside are these particles known as electrons. Here's a GIF, an animation. Again, it's not a real atom. This is also a visualization. On the inside, it's tougher to see, but there's this darker, almost black circle here. There are these goldish circles here. Maybe this is the neutron. Here are the protons, and going around are the electrons. Okay, those are the three parts. Now, different types of atoms, and there are many different types, over 100 different types of atoms. How we qualify them, how we classify them is based on how many protons that atom has. And, you know, kind of by lesser extent, also how many electrons, all right? For example, you've all heard of the word oxygen. Oxygen is important because it is an atom that we use in respiration, in breathing. We won't get into the biology of how and why, but oxygen is a type of atom. It's one of the smaller atoms. It has 8 protons in its center. That's what defines oxygen. Any atom that has 8 protons, we call it oxygen, okay? Now there's another type of atom, a much bigger atom. It is called gold. Of course, you've all heard of gold. Gold is a metal. What makes gold gold? Gold is a metal that has atoms which have 79 protons in it. So both these pictures here are showing the number of protons, and then you can also kind of also distinguish the number of neutrons. This one has a lot more neutrons as well, and then also gold has a lot more electrons. If atoms are balanced, they often have the same number of protons and electrons, but that's not always the case. But the different types of atoms, how we distinguish them, is based on how many protons. If you've taken chemistry, this should absolutely look familiar. This is the periodic table. This is how scientists organize all the different types of atoms. The very smallest one is known as hydrogen. Hydrogen has 1 proton. The next smallest is helium, because how many protons does helium have? 2. It has 2, the next smallest number you could have. We're not going to go over this whole thing, and admittedly, team, at least in the short term, we are not really going to be diving deep into this periodic table, but it does show the different number, the different types of atoms that are in here, all right? So those are atoms, things that make up our universe. Now, there's another property that we need to talk about since we're discussing atoms and protons and electrons. You are, of course, familiar with the idea of mass, all right? We've learned about mass in my own sequence of videos. All objects made up of stuff have mass. Mass is kind of like how we quantify inertia. A train has a lot of mass, it has a lot of inertia. We're all familiar with mass, even maybe before you took this physics class with me. It's a property of matter. Objects in our universe have this property known as mass, all right? Well, charge, it's not quite as explicit, meaning it's not quite as obvious to us as this guy is right here, but charge is also something very fundamental to our universe. It's a property of matter, but it's one that we don't experience every day, at least not obviously. Now, charge is related to electricity, so anytime you're using an electronic device, including maybe the Chromebook that you're watching this video on, that does involve charge. If you've ever had like socks on and you've like rubbed your feet against the carpet wearing those socks, you might feel that static charge when you touch a doorknob or something. That is also charge. So it is in fact something you experience, but to be honest, besides the smartphone or the TV screen that you're looking at, like touching a table or just looking around, maybe charge isn't super obvious. Now, scientists have realized that there's actually 2 different types of charge. There's only one mass, but it turns out there's 2 distinct ways to look at charge, and how scientists describe them is because there are 2 different ways and they kind of act like opposites. They call them positive charge and negative charge. Well, in atoms, different parts of atoms have a positive charge and different parts have a negative charge. Here's this diagram of an atom again. I got my electron, proton, and neutron, but now it's signifying the charge that these objects have. Now, neutrons, I'm actually going to start down here. Neutrons, we're not going to talk a whole lot about because neutrons don't have a charge. You might say they have a charge of 0, or you might say they're neutral. But protons, those things that are in the center of atoms, they have a positive charge. And the electrons, things that are going around orbiting the outside of atoms, it turns out they have a negative charge. So there are 2 types of charge, positive and negative. And protons have a positive charge, electrons have a negative charge, neutrons don't have any charge at all. Now, with charge comes something known as attraction and repulsion. And think of magnets. That's a great analogy here. You're probably familiar with magnets. Maybe you know for sure that magnets can attract to things. Maybe you're also familiar with the idea that if you have 2 magnets, depending on how you orient them, you might get 2 magnets that are repelling, that are pushing away from each other. That is also true for charge. Charge is not exactly the same thing as magnetism. We'll actually get into that relationship later on, but it's very similar. The laws of whether or not we attract or repel is based on what charges you have. Down here, I like this diagram. There's this adage that goes, opposites attract. Maybe you've heard of that before for like dating and relationships, but it's very true for charge. If I have a positive charge and a negative charge, those 2 things like like each other. They want to attract. It doesn't matter which side is positive and which side is negative. If I have two opposite charges, they want to get closer to each other. If I have two of the same charges, if I have a positive and a positive, they don't like each other. They want to repel. If I have two negatives, they also want to repel. If I had like two dangling neutrons, you wouldn't do that because neutrons are so tiny. But if I have two neutral objects, they don't repel or they don't attract. They don't really do anything, okay? But opposites attract. Like charges, like meaning the same. Like charges, the same charges, they don't like each other. They actually would like to repel, all right? Well, all right, there's that adage again. Here's this diagram again. This is the key idea for charge, in addition to what we said earlier, that there are two types. There's positive and negative. Depending on what combo you have, you might either have attraction, things moving toward each other, or repulsion, things moving away from each other, okay? Now, team, like if you look at the table, or if you think about the seat that you're sitting at, or even your own arms and fingers, you don't notice any attraction or repulsion, even though you might think to yourself, well, aren't I made up of atoms? That's true. And aren't atoms made up of protons and electrons? Also true. So if I'm made up of all these things with charge, positives and negatives, how come I'm not actually feeling this attraction and repulsion? Well, for the most part, team, you're not feeling that because the charge are canceling out. You have trillions upon trillions of protons in your body. You also have trillions upon trillions of electrons. All of those kind of balance out. You really are in total neutral, even though you are made up of things that are positively charged and negatively charged. When you have so many of them, all those charges cancel themselves out. So it's like you're neutral. You're not attracted to the table because of this charge, because there's so many. They're all balancing. I made this really quick image. I just took an image from online and I just added in, like, maybe imagine each of these positives represents a proton. There are billions upon billions upon billions of protons in a single leaf, but there's just as many negative electrons. So overall, they all cancel out. So you do really have to zoom into the small scale to really notice charge, or you have to do a process where you unbalance things. And we'll see some examples of that. You can do things where you load up a whole bunch of electrons so that it is overall negative. But in our everyday life, things are basically neutral, with some exceptions, of course, but things mostly cancel themselves out. So we've introduced, or maybe reintroduced, this might have been review, the idea of atoms and what makes up atoms, and this idea of charge. There are two types, positives and negatives. Sometimes they attract, sometimes they repel, but also things can just kind of cancel out, so there's no obvious effect in total, and that's what's most common in our kind of large scale. All right, thanks a lot for watching this video. See you next time.